As we read through this word problem here, there's some keywords that you kind of want to look for on problems like this to help you understand what exactly it is you're looking at. So we've got a home uses water at a rate. So notice that term rate there. And they give us this equation, and it's in liters per day. Those are the units. Where T is the number of days from the beginning of the year. To the nearest liter, what is the total amount of water used from T equals 0 to T equals 100 days? So the first thing we want to talk about is that word rate right there. When we're talking about a rate is sort of like bells and whistles should be going off that we're talking about a derivative. And they're not always going to put it as a dy dx sort of format or a w prime format. Sometimes they just tell you that that is the rate. So that's first and foremost is what we're really looking at with w of t right now is a derivative. And then the next piece comes in when we're talking about the total amount of something. When we want to total something up, that's going to be an antiderivative. That's going to be an integral method. Integrals are an accumulation tool. So when we want to total something, we want to use an antiderivative. And so at the end, they want us to find the nearest liter. So if we sort of use what we know about our equation and an antiderivative, we can kind of take a look at our units and see if we're on the right track. So if I take the antiderivative of w of t, that equation they give us, dt, what units would I come out with? Well, w of t was in liters per day, so that would be liters over days. And then dt, that's with respect to time, so that's going to be over days. And so what you can see is when you go to finish this out, the days would cancel with days, and what you're going to end up with is total liters, which is what we're looking for. So on our problem, we would want to set up an antiderivative, and our bounds here are going to be 0 to 100. And what we'll be taking the antiderivative of is the equation they gave us to start with up here. So 10 plus 7 sine of t over 30 dt. The great news about this is we don't actually have to do this antiderivative by hand. This is a calculator allowed section, and so what we can do here is we can actually just pop this into our calculator and get to our answer pretty quickly. So what we're going to do is we'll take, and in y1 on our calculator, we're going to put this equation, 7 sine of, and then we'll put an x in there whenever we're graphing instead of a t. And then we're going to want to graph this thing. And as we graph it, they're talking 0 to 100 days. These are x values. That really is our x window on our calculator that we need to set. So after we graph it, we'll either as we graph it or after we graph it, whichever you want to do, you're going to want to go into your window, and you're going to want to reset your x min and your x max to match that gap there. So we would start at 0 for our x min, and we would set our x max out to 100. After that, we'll go ahead and then we'll graph this. And then from there, we'll hit second. We'll choose the calc menu, which will be the button above trace at the very top. And inside there, we're going to choose the number 7 option, which is integral of f of x dx. Once we do that, we'll go back out to the graph on our calculator, and the calculator is going to ask us 2 questions. It's going to ask us for a lower bound first. Our lower bound is just going to be the smaller number here, so we would type in 0, hit enter. It's then going to ask us for an upper bound. Well, our upper bound for this one would be 100. And then hit enter. It'll shade in the graph the area between the curve and the x-axis, and at the bottom of the screen it's going to say integral of f of x dx equals, and whatever that value is right there, that's going to end up being our answer. So I open up my calculator, I go to my y equals. Make sure you're in radian mode when you're graphing on these things. The AP test is entirely in radian mode, so keep your calculator in radian mode. Type in the equation 10 plus 7 sine of x divided by 30. And then before I actually graph it, I would go ahead and adjust my window right now. So I would hit window, set that x min to 0, set that x max out to 100. I adjust the scale on here. That's just where the tick marks are on the graph. I just like my graphs to look nice. That's just me. You don't need to adjust the scale unless you want to. We then hit the graph button. And I can kind of see a bit of my graph. I don't actually need to see the graph itself when I go to use this process. So from there, I'm going to go second, choose that Calc menu, which is the button above Trace at the very top, and then inside that menu I'm going to choose the number 7 option, integral of f of x dx. I hit enter on that, and at the bottom of the screen it's asking me for my lower limit. So the lower limit on this problem was our lower bound, that would be 0. I type it in and then hit enter. Then it asks for the upper limit. So then I do the same thing. I type in 100 this time. That's my upper limit. I hit enter. You can see it shade in the graph, and at the bottom of the screen, right below the graph, you see integral of f of x dx equals 1,416. They want it to the nearest liter, so we would round that to the nearest whole number, which would round us to 1,416, and that would be our answer. So 1416 is our answer, which is option C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.